Bees are capable of many complex behaviors. They can learn complex associations between stimuli and rewards, and are able to find sources of nectar several kilometers distant from the hive and return to these with great accuracy. The Green Brain Project aims to understand how these behaviors are performed by building computational software models of the bee brain, based on the best scientific understanding of the neural structure and function. A ground-up approach will be used, based on the philosophy that it is not possible to understand the complex behaviors without first understanding how the sensory systems transform information from the world into information that can be used in these behaviors. To this end, we have started by investigating the neural basis of how the bee flies through its environment, how it avoids walls and floors, and selects appropriate speeds of flight. Unlike humans, bees have a very wide-angle, very coarse field of vision, and this has a large effect on how they process visual information from the world. I shall now introduce the tools used in this investigation. First is a model environment that replicates the way that the bee sees the world. They can see colours, but they are different colours to humans, and the motion detection pathway modelled here does not use colour, so this environment is currently grayscale. For speed, this visual field is even coarser than that of the bee. A simple corridor with black and grey gratings is used to test the model, allowing for a controlled environment with a known spatial frequency. There is also a top-down view showing the location of the bee in this environment and a trace of its prior positions. Here is a model of the bee's neural systems. It detects angular velocities in the left, right, and bottom of the bee's visual field. We begin the simulation and the bee starts moving down the corridor. Note how the bee begins centering itself on the corridor, avoiding the two walls. This centering behavior is robust to changing the spatial frequencies of one of the walls. If the width of the corridor is changed, then the bee speeds up in order to maintain the total angular velocity on its receptors. The project will build on this work and add more neural circuitry to manifest more complex behaviors. Thank you for listening.